Hello, hi to everyone. In this video, we are going to discuss analog low-pass Chebyshev filters. In the previous video, we have discussed design of Butterworth filter. In this video, first we will discuss the concept of Chebyshev filter. Then we will discuss the problem of analog low-pass Chebyshev filter. We know that we have two methods to design analog filters. One is Butterworth, second one is Chebyshev. In the Chebyshev, again, they are classified into type 1 and type 2. Okay, in the type 1 filter, all pole filters, that is here there is no zero in the transfer function in the filter. Okay, just we have only poles are exist. Okay, therefore equiripple, this is the equiripple. The equiripple exhibit in the pass band. There is no ripple in the stop band. Here here we will here we see only the monotonic, okay, monotonic behavior or monotonic characteristic. That is, here there is no ripples in the pass band. Such type of filter we call this one as Chebyshev type 1, right? So this is the Chebyshev type 2. In the Chebyshev type 2 filter contains both zeros, okay, both zeros and poles, okay, and it exhibit monotonic behavior in the pass band and equiripple in the stop band. So this is the type 2 Chebyshev filter. In the overall, what is type 1, type 2 Chebyshev filter means, if they are asking in the exam, if the ripple, equiripple exhibit in the pass band, such type of filter we call type 1 Chebyshev. If the equiripples exhibit in the stop band, such type of filter we call this one type 2 Chebyshev filter. Okay, again they have divided the Chebyshev filter as a n, if n is even and n is odd, then the frequency response characteristics looks like this, right? This is the low pass Chebyshev filter magnitude response. This is not a phase response, this is the magnitude response. See here how we have to distinguish the this is a odd, um, n is a odd and n is a even, right? So here the ripple factor starts from the magnitude 1, then it is a odd type of Chebyshev filter. If the magnitude starts from 1 divided by square root of 1 plus epsilon square, here if it is not start from magnitude 1, it is starts from here, then it is a Chebyshev filter, n is even. Okay, that's it. If the n is odd, then the ripple factor starts from magnitude 1. If n is even, then ripple factor starts from 1 divided by square root of 1 plus epsilon square. Okay, this is very very important. I think you know the basic concept of magnitude response characteristic. That is, this is a, I will show you in this. This is a pass band attenuation, right? So alpha P, this is a stop band attenuation. That pass band attenuation occurs from 0 to pass band frequency, that is represented by omega P. This is a capital omega. Okay. So in order to represent analog frequency, we are using capital omega, this one, right? So the pass band attenuation lies between magnitude 1 and 1 divided by square root of 1 plus epsilon square. The stop band attenuation lies between the magnitude 1 and 1 divided by square root of 1 plus lambda square. This is epsilon square is the parameter related to pass band. Lambda is a parameter which is related to stop band. This is very very important. So alpha p is equal to 1 divided by square root of 1 plus epsilon square. Alpha s is equal to 1 divided by square root of 1 plus lambda square. Then that stop band frequency lies between 0 to omega subscript s. Okay, this is the basic concept of magnitude, the parameters related to the filter. It may be a Butterworth filter or it may be a Chebyshev filter. Okay, and usually the x-axis is a analog frequency. That's all. This is a magnitude of filter, right? H of j omega. This we are representing between the modulus h of j omega. Okay. Um, this is the characteristic of type 1 and type 2 Chebyshev filter. This is the low pass Chebyshev filter magnitude response. That is, in order to distinguish n is odd and n is even. Okay. These are the formulas, right? So in order to find out the order of the filter, okay, just you have to memorize this formulas, okay, or equations. So while discussing the problem, while discussing the problem of Chebyshev filter, we will see these formulas there. Okay, just note down these formulas. You will get these formulas in any DSP book. I have seen these formulas in the Ramesh Babu book. It is that 7th edition, right? Digital Signal Processing 7th edition, written by Ramesh Babu book. You can also see that book. Okay, it's very very easy to understand the concept, and also you can refer the Nagurkani book, Chittod books, okay, from the exam point of view. Okay, so the magnitude square response of nth order type 1 filter. Type 1 filter means all pole filters. There that equiripple exists in the pass band, right? So that the magnitude response h of j omega can be represented using by equation 1, right? This is the equation 1. N is the order of the filter, okay, where epsilon parameter, this is the parameter of the filter related to the ripple in the pass band. It is related to the ripple because as it is a type 1 filter, the ripple factor exists in the pass band. So this is the parameter related to the ripple in the pass band. What is that C subscript n of x? This is the nth order Chebyshev polynomial equation. Okay, polynomial equation. It can be defined as, so it that equation is different for both the pass band and stop band. So we will get different equation. So Chebyshev polynomial equation for the pass band and stop band. This concept is not that much important from the exam point of view, but if you want to understand what is Chebyshev, or if you want to do more research in this, you have to refer more books. But it is overall the concept of the Chebyshev filter. Okay, I am not going in depth. So from the exam point of view only I am explaining. If you want to do research, if you want more knowledge in this concept means please refer the book, any book. So C subscript n of x, cos of n, cos inverse of x. If the x, the value of x, right? The value of x, the modulus of x is less than or equal to 1, then it is a passband equation. Actually, x lies between less than or equal to 1, then it is a passband equation. Then if the x is greater than 1, if x is less than or equal to 1, means it is a passband. This is the equation. If x is greater than 1, it is a stop band equation. The ripple factor exists in the stop band, right? So then x is greater than 1, then the equation is this one. Okay. Chebyshev polynomial is defined by the recursive formula. This is the recursive formula of Chebyshev. Okay. So for n is greater than 1. N means the capital N is the order of the filter. Okay. Where if C subscript if n is 0, the order of the filter is 0 of x means C subscript 0 of x means the value is 1. C subscript if n is equal to 1, the value is x. Okay. Here we can see some properties related to the Chebyshev polynomial. These are some of the properties. These properties are not that much important. Just I will read out these things. C subscript n of x. For n is odd. You know this. This is the basic concept of signaling system, right? So C subscript n of x means minus Cn of minus x. If it is even, so here we won't get minus symbol. Cn of x is equal to Cn of minus x, right? If it is n is even. For n is even, for Cn of 0, so in the bracket minus 1 of n by 2. So if for n is equal to odd, for n is even, for Cn of 0, minus 1 to the power of n by 2. If n is odd, Cn of 0 is 0. For all n, if it is, for n is vary from 0, 1, 2, 3, 4, whatever it is, right? For all value of n, if it is even or odd, Cn of 1 is equal to 1, right? So for n is even, Cn of minus 1 means 1. For n is odd, Cn of minus 1 is equal to minus 1. Just here you have to substitute. If it is minus 1 means you will get minus 1, right? Here inside the Cn of minus Cn of minus 1 means minus 1. If it is n is even, if it is minus 1 means you will get 1. That's all. Here we won't replicate that minus symbol in the even. In the odd symbol we will get minus 1. That's all, right? And that Cn of x, the nth order Chebyshev filter polynomial equation, the triple factors, the oscillates, the triples oscillates between plus or minus 1. Okay, this is the ripple factor, right? This is the ripple factor. So this ripple factor ripples between plus 1 and minus 1. Okay, so x is lies between plus or minus 1. Okay, so for x is less than, modulus of x is less than 1. Modulus of, if we are not putting x means, modulus means how we will write? Plus or minus 1. If we are putting inside the modulus, x is putting inside the modulus, then the value of x is always should be plus. Even if it is minus means we are indicating the value, we are representing the value by plus symbol. Always it is positive, less than or equal to 1. For all n, I mean the order of the filter is for all value of even and odd, right? If it is even or odd, if the x is lies between 0 to 1, then Cn of x is lies between 0 to 1. If x is greater than equal to 1, then the value of Cn of x is greater than 1. Right? It is similarly, the x is The ripples between 0 to 1 means the CNFX value also lies between 0 to 1. If X value is greater than more than 1, 1.5, 2, 3 like this, so the value of Cn of X is also greater than 1. So the value of Cn of X is gradually increases or monotonically increase for X is greater than. The X value is, the ripple factor is greater than 1 for all value of n means the Cn of X value is gradually increases. It does not decreases. Okay. So already I have explained this concept. I don't want to do again. Okay. I think you are able to understand the concept of overall concept of Chebyshev filter. Okay. So in the next video we will discuss the design of analog low pass Chebyshev filter. Okay. If you like this video, give thumbs up, share this video, subscribe my channel. Thank you very much.